In this video, we're looking at photoelectric effect. So this is a series of photoelectric effect. So we did previously in a previous video introduction of photoelectric effect and then with a question. So in this video, I'm going to go straight to the question. So please, if you haven't watched the previous video, do so because that is an introduction, and then also it can help you to understand what I'm doing in this question. Okay, question 10. Light is incident on the cathode of a photoelectric cell connected to a battery and a sensitive ammeter as shown below. So you have a light incident on a cathode, and then you have a circuit connecting the cathode to the battery as well as the ammeter. We know that ammeter measures what? Ammeter measures current. So this is the ammeter that measures current, and then we also have the battery. So what we need to do here, we need to understand that current is the rate of flow of charge. The charge that we are talking about here is electrons. We know that electrons are the one flowing through the circuit, right? So 10.1 says, what conclusive evidence about the nature of light is provided by the photoelectric effect? So photoelectric effect helps us to understand the particle nature of light. That light has a particle nature, which we call that particle photon. So that is the answer for 10.1. 10.1, the answer is that it gives us the evidence of particle nature of light. Or in one term, you can say that it quantized, light. We know that if you quantize light, it simply means that you break it into the smallest unit, which we call this particle. So it quantize the light. Okay, so that is 10.1. okay, so let's look at 10.2. So just to explain briefly on 10.1, remember that when you shone a light on a cathode or any metal surface, because of that nature of light, the particle nature of light, each photon, which is the particle of light, it strikes the electron, and then it transfers the energy from the photon to the electron, and then hence the electron can be ejected, right? So each photon strike each electron to transfer energy, and then the energy is being transferred from the photon to one electron. So each photon each to a single electron. Okay, so let's look at now 10.2. So 10.2, so before 10.2, we can see here that they are saying the cathode has a work function 3.42 times 10 to the power of negative 19. So 3.2 here, this is the work function. Work function is represented with a symbol WO, which is work function, right? So 10.2 define the term work function. So what is work function? So work function is the minimum energy. So work function is the minimum energy. Is the minimum energy of light. Is the minimum energy of light needed or required to emit or eject electrons from the metal surface. So it's the minimum energy needed to eject electrons from the metal surface. So that is the definition of work function. All right. So then let's look at 10.3. So 10.3, the question for 10.3, it says light of frequency 5.96 times 10 to the power of 14 hertz is shown on the cathode. So here you are given that the light carries a frequency of 5.96 times 10 to the power of 14 hertz. That is the frequency. Okay, so on the cathode, is shown on the cathode. Calculate the maximum kinetic energy of an electron ejected from the cathode. So if you are looking for kinetic energy and then you are not given a velocity or the speed of the electron, so you have to use the formula that we use for photoelectric effects, which is energy of a light, E, energy of light is equals to work function plus the maximum kinetic energy of an electron, right? So the minimum, the energy of a light equals to work function plus the maximum kinetic energy of light. So this formula here actually is given in your formula sheet, so you don't have to memorize it. It's given in your formula sheet. So this is the formula here for photoelectric effect. This formula here is given, so you don't need to memorize it. All right, so what is the value of E? What is the value of E? So the value of E represent the energy of light or energy of photons. So what you need to do here is to just break it. We know that E is the same as we know that E is the same as what? Planck's constant multiplied by frequency. Or if you are given wavelength, it is hc over wavelength. So any of this formula will work. So in this case, we are given frequency, so we're going to use the first one, the top one, that energy of light is Planck's constant multiplied by frequency. So that is E is equals to HF, and then work function is given as 5.96 times 10 to the power of 14, and then plus the maximum kinetic energy. All right, so H is a Planck's constant, which is given in your formula sheet. So Planck's constant is given in your formula sheet. In this case, this is the Planck's constant. This is the H. So it's 6.63 times 10 to the power of negative 34. So 6.63 times 10 to the power of negative 34 times the frequency. Frequency here, they gave us frequency as 5.96 times 10 to the power of 14 hertz. And then that is equals to the work function 5.96 times 10 to the power of 14 plus the maximum kinetic energy. So if you do your calculations here, you will see that when you multiply these two here, 6.63 times 10 to the power of negative 34 multiplied by 5.96 times 10 to the power of 14, it gives you 14 to the power of 14. It gives you 3.95 148 times 10 to the power of negative 19. Yeah, so when you multiply those two, they give you that as an answer. And then you have 5.96 times 10 to the power of 14 plus maximum kinetic energy of electrons. So when you do your calculations, you take 5.96 to the other side. So kinetic energy, the maximum kinetic energy will be, so you just subtract here the answer, then you say minus 5.996 times 10 to the power of 14. So if you do, okay, let me do this. So this is, and then if you say that answer, subtract 5.96 to the power of 14, it's 5.96, actually not 396 to the power of negative 19. It should give you, I think there is somewhere that I made a mistake. Let me see. Work function is 3. Yeah, so work function, sorry, I made a mistake with the work function. It's supposed to be so this is not, I took the wrong one. So here it should be 3.42 times 10 to the power of negative 19. So I'm the one who took the wrong. So I'm just gonna fix it there. So work function, it should be 3.42 times 10 to the power of negative 19. Yeah, 3.42 times 10 to the power of negative 19. All right, so let me also fix it here. Okay, so 3.42 times 10 to the power of negative 19. Okay, there we go. So now when you subtract that from the answer of the left hand side answer, which is, you subtract, you get 342 times 10 to the power of negative 19. So it gives you kinetic energy as 5.31 times 10 to the power of negative 20 joules. So that is the answer for the kinetic energy of electrons. Okay, so the key part here is the formula that, like I said, the formula is given. So in your formula sheet, just remember that this formula here is given in your formula sheet. And then also to note that if you have frequency, you are going to use this formula here for energy of light. But if you are given the wavelength, you are going to use this formula here for the energy of light. Okay, so yeah, that is the answer for 10.3. Okay, so I'm gonna go to 10.4. So that is 10.3, 10.4. Okay, so yeah, there we go, 10.4. So let's look at 10.4. So 10.4, it says here that the ammeter register a constant current. So here you have current. So you have current here of 0.12 amps or amperes. And then calculate the minimum number of photons. Minimum number of photons of light that strike the cathode in 10 seconds. So you already have the time, you have the current, and then you also have the time. So we know that if we are calculating the number of photons, the only way to get number of photons is to get number of electrons, because each photon strikes one electron, and then in that case 1 photon for 1 electron. So therefore the number of photons emitted or that are incident on the cathode is the same number of electrons that are ejected. All right. So in that case, if you calculate number of electrons, the number of electrons, when you're gonna use this formula, number of electrons is that is 10.4. Number of electrons is charge on a metal surface divided by the charge of an electron. This is the formula for number of electrons. So because this charge of an electron is a constant, so you need to find Q. You need to find Q here in order to calculate number of electrons. So how are we going to get Q? We are going to use first the formula. In order to calculate that, we need to first get the charge. So how do we get charge? We know that current is the rate of charge. Current is the rate of charge, or is charge over time. So charge over time is what? So charge over time is current. So in this case, if you want charge will be current multiplied by time. So the current, we have the current, which is 0.012. By the way, this formula here is given in your formula sheet. This formula here, you have it in your formula sheet. This is the formula here. This is the formula. You have it. Yeah. So the charge current is what? Current is 0.012 is given, and then the time they give us is 10 seconds. So if you do multiply the 2, you get 0.12 coulomb. That is the charge. So once you get the charge, that is the charge, because if you say 0.12 multiplied by 10, that gives you 0.012, that gives you 0.12 coulomb, or 0.12 coulomb. So once you have the charge, you can substitute it to this formula here, and then get the number of electrons. So once we have that, we're going to substitute it back to this formula here. Charge over charge of an electron. So charge of, we got it as 0.12, and then charge of an electron is a constant, which is 1.6 times 10 to the power of negative 19. So you have it also in your table of constants. So you have it there. This is the formula, or the constant for charge, the charge of an electron. Okay, so that you don't put the negative, you just put the number, not the sign. So 0.12 divided by 1.6 times 10 to the power of negative 19. Let's do that. Calculate. This is gonna be 0.12 divided by 1.6 times 10 to the power of negative 19. It gives you 7.5. It gives you 7.5. Okay, 7.5 times 10 to the power of positive 17. So this is the number of electrons. Okay, so that is the number of electrons. So this is number of electrons. So like I said, each photon ejects one electron. So if you know the number of electrons, that will be the same as the number of photons. So therefore, number of photons is 7.5 times 10 to the power of 17 photons. That is the answer for 10.4. So the key part here with this question is that you need to know that this formula also here, for especially the key formula here, is this formula of number of electrons. So that is the key formula here that you're going to use in order to get number of electrons. So you just need to know that that formula also is given in your formula sheet. Here is the formula, or you can also use this one, but it's the same formula. It's just that the other one they use E for charge of an electron, and the other one is QE. So but it's the same formula. You just need to know that you have that in your formula sheet, this formula here. Okay, so that is 10.4, and then let's look at lastly 10.5. So I'm going to take this out. So let's look at lastly 10.5. 10.5. So 10.5 here, they're saying that not calculate, but the intensity of incident light or intensity of light is now increased. How will this charge, how will this change affect the reading on the ammeter? What ammeters do is to measure the current or the rate of flow of charge or the rate of flow of electrons. So meaning that we know that what is the role or the effect of increasing incident light or increasing the intensity of light. We know that intensity increases the number of electrons emitted. So if intensity increases the number of electrons emitted, that means that the current will increase, because also current is the flow of electrons or flow of charge. The higher the number of electrons ejected, the higher the current, and then in that case, that is the answer for the reading on the ammeter will increase. Okay, so let me just write it down. So the first thing to note here is that intensity, let me write it down, high intensity of light. First, it increases what? It increases number of electrons emitted or ejected. And then if the number of electrons emitted or ejected increases, the charge, the rate of flow of charge will increase. And then if the rate of flow of charge increases, current increases. And then if current increases, therefore the reading on ammeter reading will increase. Ammeter reading will increase. Because we know that current is directly proportional to what? To charge. The higher the charge, in this case, the higher the number of electrons, also, therefore, the higher the current. And then if the current increases, therefore, the ammeter which reads the current, it will increase. The reading will increase. So that is the answer for 10.5. Okay.